Hello, my name is Danny Nowlan and I'm the Director of ChassisSim Technologies. In this latest video tutorial, what we're going to be discussing is creating circuit models using ChassisSim version 3.21. Now, I realize that it would have been a couple of months ago, I posted a video tutorial about how to do circuit modeling in minutes. It would have been using either ChassisSim version 3.17 or version 3.18. Now, the techniques that we're going to be discussing today are very similar to that tutorial. However, we've thrown in some new features to ChassisSim version 3.21 that should actually really aid to this. And also too, from questions I've been getting throughout the ChassisSim community, I think it's an appropriate time just to go over these skills again, and also to give you some really good, useful tips and tricks to get going. So, the first process in this is obviously to load the car file that you're working on, and I've loaded my particular formula-free car here. Now, it goes without saying that our next step in the process is that we obviously need a monster file. So, to do that, what we're going to do, so we've already got our monster file, so what I'm going to do is I'm going to go to Circuit, create Filter Curvature File. I'll click on the raw curvature monster file, and here's my monster file. I'm going to click here if using my monster import file. I change this to 50 Hertz. Now, quick question I would suggest, if you're starting off using this and you've got probably even the slightest doubt of the quality of your lateral acceleration data, I would set the frequency filtering setting to the moving average filter and set that to about 0.5 of a second. We found that to be very robust. That being said, if you've got really good quality lateral acceleration data, by all means use a frequency filter. But for the purposes of this exercise, I'm just going to use the moving average filter. So I click on my output curvature file, and I'm just going to call this TR, standing for track, and then I usually put in the circuit name, which is in this case Sandfort, and I'll just preference that with a suffix called track Sandfort F3. And I'll click on open, and I click on OK, and you're done. That's your curvature file done. Now, in most cases, you probably really don't need to even look at it. I personally, what I like to do is I will like to go into Edit Variable Grip Factors, and I'll import that curvature file just to make sure it looks relatively sensible. It's a quick sanity check that I like to do. Now, obviously, the next step is going to be doing the bump profile modeling. Now, you'll notice in version 3.21 there are a few actually new features in ChassisSim version 3.21 that I'm going to discuss in just a moment. But obviously, the first step is we're going to import the monster import file, and if we are going to be using auto bump scaling, make sure that sign of your lateral acceleration is set correctly. Now, in this case, it's -1. Now, once again, we go through and we set through our various parameters, and you'll notice in version 3.21 they actually come out to being the defaults that are pretty close. Now, one thing I want to talk about is the maximum bump rate. Now, this is an open wheeler, so rough rule of thumb for an open wheeler, start at a maximum bump rate of about 0.2 meters per second. If you're dealing with something like a really softly sprung touring car with very little downforce, you can go 0.3 up to about 0.4. Also, too, make sure that if your dampers are zeroed on the deck, you set the zero flag to 1, and you set your maximum bump value, a maximum droop value. A good starting point is about 30 mil. Now, one of the things that's new in version 3.21, I'm going to click on Allow Auto Bump Scaling, and you'll see here maximum number of bump scale iterations. What that does is that basically allows you to spec out how many iterations the auto bump scaling is going to do. And we've actually found that to be a very, very useful way of really getting in some really, really to really make sure the bump scale properly. So I'm going to set that to 5, and I'm going to click on Create Bump Profile, and I'm going to now click on OK to run the bump profile. So what it's going to do is it obviously does its frequency analysis. So we're just going to let that run for a minute, and we'll get right back to you. Okay, now we've done our frequency scaling, and you can see right now it's actually going through, and it's doing its it's actually now going through and doing this auto bump scaling. And when it gets done, it gets done. Now, those numbers that you saw were actually just sort of a percentage different, were sort of like a factor between simulated bumps and actual bumps. And as you can see, that we were upping our bump intensity to make sure that we really captured those bumps appropriately. Now that we've got that, you've really got a fork in the road here. If you're dealing with circuits that have very little that have very little altitude road camber in, then what I like to do is I will load in the curvature and the bump profile and run an initial simulation just to see where things are at. However, Zandvoort is a circuit with significant altitude road camber variation, so I'm going to need to run that. So all I'm going to do here is I'm going to go to my edit circuit altitude camber and generate circuit altitude road camber. I should say from the get-go that if you've got GPS data, by all means, go through, import your curvature file, and import your GPS data. Let me just actually walk you through briefly what that looks like. If you go into generate circuit altitude road camber, you could, my bad. If you go to edit the current circuit altitude road camber and we go into import our curvature file, you'll see here import circuit altitude from GPS. What that will do is that will import a data export of your GPS data and will assign your altitude data. So if you've got that, by all means use it. If you don't, you basically go to generate circuit altitude road camber. We click here to import our monster file. And what we do here is we basically import the curvature file that we were using. And we also import our bump profile. Now, usually you can just basically import your bump profile without even looking at it. Personally, because because I tend to be a little bit finicky, I just like to have a quick look at a notepad just to make sure it doesn't look too silly. And as we can see here, it hasn't done anything particularly outrageous. So I import my bump profile. And now I'm going to specify where I want my desired altitude road camber to live, which is altitude road camber Zandvoort, and I'm going to click on open. And now I'm going to click here to generate my altitude road camber. I make sure that my sign of my lateral acceleration is correct for my data, which in this case is -1 because left-hand turns are recorded as positive G. And in this particular data set, right-hand turns showed positive steer angle. I make sure that my loads are zeroed on the ground, which is the case for this monster file. Now, if you're really confident in your aero map, you can click on here to generate elevation from damper data. I would only do that if you are ultra confident in your aero map. So leave that clicked off. So now we basically click on OK. And now it's going to do its thing, and we've generated our altitude road camber file. So what we're now going to do is let's load that up. Now, what I'm just going to do very quickly is just do some housekeeping here. I'm just going to rename this bump profile file to bump profile Zandvoort F3, and I'm going to click on that and click on OK. So what I'm now going to do is I'm going to go to circuit data. I'm going to load in my curvature file, which is my track Zandvoort F3, my bump profile, which is, I go to file filter star.dat, bump profile Zandvoort F3, and I'll import my altitude road camber file, altitude road camber file Zandvoort, click on use altitude road camber, click on OK, I'm good to go. So what I'm going to do now is I'm going to basically do a data log just to see where things are at. So I'm basically going to basically set up this data log. I'm going to call it Zandvoort, and I'll call this a NIT baseline. And I'm going to click on data output, put it in my data folder, and I'm just going to call this F309 initial baseline. Okay, so what we're going to do is we're going to start the simulation, and now we're just going to let it do. Now we're going to let it do its thing, and we'll get back to you at once it's finished its lap time simulation, and we're going to compare some data, and we're going to have a look and see basically what the appropriate direction to go in terms of our circuit refinement is. Okay, so we're now done, and that's our simulated lap time. All right. Now, what we've done here is we've got our analysis software up, and now let's have a look and take a look at our initial baseline. We take a look at that, and what I'm going to do, and this is just my personal preference, I make sure that my baseline lap is colored and my initial overlay is simulated. So we have a look at that, and we have a look at that, and we just take a look and go, oh my Lord, we've got a terrible tragedy, particularly here and here. Okay, before you hit the panic button, let's just go through and just take a look and make sure that we've got quite a few basics, quite a few basics sorted out here. First things first, let's take a quick look at the suspension histograms. Right. The suspension histograms are in the money. So what that basically means is we've actually done a pretty good job of our bump profiling, because in particular, going into this particular corner here, you can see that we've really matched the actual severity of our bumps to what's actually going on with the car. If anything, we could almost probably take it out a little bit, and I'll show you how to do that in just a moment. However, we're taking a look at basically this corner here and this corner here. Now, let's just take a look at what's going on here. What's going on here is that basically ChassisSim has tripped over a bump. Now, what's happened? Now, the way we would solve that in the past is we would go through and apply a bit of bump scale factors to just smooth that out. However, what we've got, but to quote the Joker from The Dark Knight, I'm going to show you a little bit of a magic trick. Let's click on Advanced Options. If you ever see a situation like in this particular turn or in this particular turn or here where it's obvious it's tripped over a bump, this is now your first protocol for version 3.21. We're going to click on Allow apex speed to be determined by corner length, and we'll specify percent of the corner length at 5%. Now, up till now, the algorithm in ChassisSim has been it's applied a very, very tight distance tolerance for actually determining the apex speed. Now, if the bumps aren't too crazy, it actually works really, really well. What this does is it basically shifts that to basically determining the apex speed by the combined turn-in and apex length or mid-corner length of the actual corner. So we're going to set that to 5%. So what we're going to do now is I'm going to click on OK to apply that. I'll just click on Cancel to get out of there. I'll set up another data log run, and I'll just call this with apex tolerance at 5%. And you'll see here like a little magic trick I'm doing with the data logging is rather than clicking on data file output, the data file output name tab, what I'm actually doing is I'm actually manually typing it in. This is actually a really quick way of making sure that you don't have to go through and hunting through files. All right, let's click on Start Simulation and see what that does. So as you can see, almost from the get-go, you notice that last time that we had an initial apex speed of about 96k an hour. Take a look at the impact that's had. That's taken it from 96 to about 110 kilometers per hour. So what we're going to do is we're going to let ChassisSim do its thing, and we'll discuss this once the simulation is finished. As we can see, we've now got a significant improvement on the actual lap time, which is about a 93.6 seconds. One thing I do want to bring to your attention, take a look at the increase in corner speeds here by basically allowing, by turning on that apex distance tolerance and setting it to about 5%. Okay, let's now have a look at what that actually did. So here's my apex tolerance at 5%. I'm going to add that. And now what I'm going to do is, once again, I'll make sure my baseline is red and my apex tolerance is at 5%. And as we can see, that is a pretty significant improvement on what we had. Now, just a couple of things to bring to your attention. I'm just going to have a quick look at the histograms. Now, looking at basically there, I actually think there's probably a little bit of a case here for us to actually reduce the scale of to actually reduce the bump scale factors, because if we take a look at particularly going through this corner here, you can tell that we've probably over magnified some of the bumps. So what we're going to do is I'll walk you through how to refine that, and I'll walk you through how to refine that in just a minute. But as you can see, that little flag that we just discussed of switching over to the apex speed determining by corner length and setting it to about 5%, has really brought us right back into brought us right back into the game here. Now, at this point, my next step now is I'm just going to just take the edge off the bumps a little bit. So to do that, I'm just going to go into circuit data, and I'll shift the bump scale factors to about 0.8. Now, the other thing that I'll also do is I'm going to go back into my simulate window. I'm going to click on my advanced options. I might just shift that down to about, what I might do is I might just shift it down to, actually, no, I'll leave that at 5%. But if you do find that it's over predicting the corners using this flag, a good rough rule of thumb is that you actually drop the percent of the percent of the corner length. So we've set it to 5%. We've tested it all the way from 3% to 10%. So it will determine basically on what your car is like. But look, 5% is a good place to start. But we'll just leave it at 5% for the time being. And what I'm going to do is obviously I'll just go bump scale factor at 0.8. And I'll go bump scale factor at 0.8. And we click on OK. And let's start the simulation and we'll see where we're at. Okay, so we're getting back to the end of our simulation, and so we'll just wait for that to wrap itself up. So that's again an improvement. Let's have a look at some data and see what it did. Okay, so bump scale factor at 0.8. Click on open, and so compare that to my actual baseline. Put my bump scale factor, and as we can see, this time around, it's actually doing, as we can see, we're getting closer and closer and closer. Now, when you're at this point, you're ready to apply you're ready to run the auto grip. Now, if I was to run this completely in, if I was to run this in complete, in complete fire and forget mode, I would have automatically have gone curvature file, bump profile, altitude, road camber file, auto grip scale, then done the auto grip scaling factor. However, I've done it this way so you can actually see what's going on, because just remember, our goal here is to create as good a representative environment as possible as the race car. So let's have a quick look. Suspension histograms, we maybe could have gone maybe a little bit too far with that bump scale factor. Maybe we should have gone to about, say, 0.9. But as we can see here, particularly where it counts in the corners, I mean, we're basically pretty much bouncing at the same magnitude. Particularly through some of the high speed stuff. If you're looking at stuff that looks like this is where I'm going to put my hand on my heart and say that's good. I'm going to put my hand on my heart and say that's good enough. So now that we're at this point, we're ready to apply the auto grip, the auto grip factor file. So to do that, all we got to do is just click on circuit, auto grip determination, and we click on grip factor file. And I'm just going to specify where I want this grip factor file. And I'm going to apply grip factor file, Zandvoort F3 and click on open. I'm going to run auto grip matching. And I obviously am ticking off that I'm using model bumps, use altitude camber file. I'll click on OK. And now what it's going to do, it'll simulate a lap to create the grip factor file. So what we're going to do is we're going to let it go off and do its thing. And we'll come back when it's done. So we're now done. We've done our auto grip calculation. So all we need to do now, we'll go to circuit data. Let's load that in. And we'll go grip factor Zandvoort F3, click on OK. And now let's run this with bump scale factor plus our grip factor. And obviously we'll create the appropriate data file for that. And we'll rerun the simulation and we'll see where we're at. Okay, so we're getting to the end of our simulation here. All right, so that's our simulated lap time with our auto grip. And now what we're going to do is let's have a look at basically what that looks like. Right, so what I'm going to do is I'll click on my bump scale factor with my grip factor, click on open. And what I'm now going to do is I'm now going to overlay that with the actual data. Okay, so here we go. Now, if I'm looking at something like this, I would probably stop at this point and go, that's good enough. I mean, look, there's probably, I would need to specify a gear ratio here because here I've pretty much, it's pretty obvious that the simulator is short shifted here. If I wanted to get anal, I could probably go into here and basically tune with the grip factor a little bit more, or alternatively, what I could do is I could go into my advanced options here and up that, say, to about 7 or even 8, 7 or about 8%. But if I was to do a rough and ready simulation at that point, I know I'm pretty much good enough to pull that at this point. I'm pretty much good enough to pull the trigger. Another thing that you could do at this point as well particularly if the bumps were going out of control, is to manually go into the edit variable grip scale factors and actually just tune the bump scale factors there, just to bring that corner speed into into line. But as a general basis, I would look at something like that, and I would just figure, you know what, I'm pretty much at this point, I'm pretty much good to go to do my simulation work. Yep, team management might get a little bit grumpy with, say, this correlation here and that correlation there, but honestly, at the end of the day, ladies and gentlemen, your job as an engineering professional is to create a representative environment. You don't get brownie points for the world's most perfect correlation. What you do get brownie points for, and ultimately saving your job, is basically results on the track. So never ever lose sight of that. So to review, what we do is we create a curvature file. We then use our go through and we create our bump profile, and that's something that's very key. If we really want some good bump fidelity, we click on allow auto bump scaling and we play around with bump scale iterations. That'll vary from car to car. 5's a very good number to start with. If we need to, we generate our circuit altitude road camber file, and we then do an initial simulation. Then we do an initial simulation to see where we're at and what we need to do. If we've got really big corner discrepancies, like here, our go-to in ChassisSim version 3.21 is to click on Advanced Options, click on Allow Apex Speed by Corner Length, and start off at about 5%. And as we saw, that had an immediate impact in terms of what the corner speeds were doing. Now, Once you're at that point, you go through, you take a look at what the histograms are doing. If it's obvious that, particularly in this case, as we can see here, the simulated bumps were going off the scale, that's your cue then to go through and reduce your bump scale factors. Now, I should say that particularly with regards to making this permanent, just remember, all the bump profile and curvature files in ChassisSim, the grip factor files, bump scale factor files, etc., they're all ASCII text files. You can open these up in Excel and manually multiply these by about 0.8. This will be saved this will be saved in your workspace. Once we're done with that, we then basically double check our correlation, and at this point, we're pretty much all in the ballpark here, and then we run the auto and then we run our auto grip scale factor to tidy our things up. Now, some other bits and pieces that I'll mention to you in terms of refining your circuit models from time to time, particularly say for a turn like this, if you find that you're throwing an awful lot of grip factor at it, it's not doing anything, you've got two options. Number one, to go in and manually adjust the bump scale factor, to apply bump scale factor to it to reduce the bump severity. Or your other option is we go into advanced options and we change our percent corner length, say from 5% to 7%. Rough rules of thumb, the maximum I would go would be something like 10%. I wouldn't go any further than that. But as I said, one of the things we found in our initial testing, 3 to 8% is a good round number. But look, don't take my word for it. For those of you who are in the ChassisSim community, you should have received your emails about the version 3.21 release. Give this a try yourself. And if you're not a member of the ChassisSim community, get going with ChassisSim Professional Online. Or if you're a member of a professional team, by all means, send us an email. We'd love to hear from you, and we can get you rolling with a demo and find out for yourself what great circuit models you can create using ChassisSim version 3.21.